Today we are going to discuss about how to estimate nitrate in water. We are using phenyl disulfonic acid to estimate nitrates in water. This nitrate reacts with phenyl disulfonic acid and forms a nitro derivative. In alkaline medium, this derivative develops yellow color. This yellow color can be measured at 420 nanometer in a spectrophotometer. Then how to prepare this phenyl disulfonic acid? For this, we should take 25 grams of phenol and mix with 150 ml of concentrated H2SO4, then add 35 ml of pyrosulfuric acid, which is fuming sulfuric acid. Then keep in water bath for 2 hours at 100 degrees centigrade. Then it forms phenyl disulfonic acid. This phenyl disulfonic acid we should use to estimate nitrates. Then how to prepare nitrogen standard? For this we use potassium nitrate, AR grade, purified potassium nitrate. We should weigh 7.2214 grams potassium nitrate and it should be mixed with 1000 ml of distilled water. Then after preparing this 1000 ppm nitrogen, we should use 1 ml of this 1000 ppm nitrogen and it should be diluted to 100 ml so that we will get 10 ppm nitrogen solution. You can see the same thing in this picture. The first figure is phenol. It is mixed with sulfuric acid, 2 molecules of sulfuric acid. Then it forms phenyl disulfonic acid in second picture. And when we mix with nitric acid, it forms nitro derivative, phenyl disulfonic nitro derivative of phenyl disulfonic acid, which is in yellow color. Based on this intensity of yellow color, we measure the nitrate ion, nitrogen content at 420 nanometers. Now, coming to the procedure. In this procedure, we should compare the sample solution with the standards, known standards. We already discussed, we prepared 10 ppm nitrate solution, nitrogen solution by using potassium nitrate. So we should use 10 ppm nitrogen solution, then take 1 ml, 2 ml, 3 ml of 10 ppm nitrogen solution in different beakers, 100 ml beakers. You evaporate it to dryness by using water bath. After evaporation, you bring them and slowly add 2 ml of phenyl disulfonic acid. Then what you have to do? Then you add 10 ml of distilled water. After thoroughly mixing, 10 ml of distilled water. When you are adding distilled water, slowly you add distilled water. Suddenly don't add this distilled water. Immediately, sudden explosion, it will come slowly, ml by ml. Slowly you add distilled water. After adding, cool it. Then add 10 ml of ammonia solution. Ammonia concentrated ammonia solution means 25% to ammonia solution, which is commercially available. Then thoroughly mix it and make to 25 ml solution in a volumetric flask. Then you take the reading, yellow color reading at 420 nanometers. In the same way, sample solution also we have to do. Take 2.5 ml of sample solution in a 100 ml beaker and heat it in water bath up to dryness. Then take that beaker, add 2 ml of phenyl disulfonic acid, which is prepared at the time. Then, after thoroughly mixing, then add 10 ml of water, distilled water, slowly. It will be in very hot condition. Keep it for cooling. Then add 10 ml of this concentrated ammonia, means 25% ammonia. Then again you mix it. Then you make the solution to 25 ml in volumetric flask. Then again you take the reading at 420 nanometers. Means you keep all the solutions. Then you have to take readings, not individually. Individually we should not take. All the sample solution and standard solution you should take at a time at 420 nanometers. You keep all the things ready in a 25 ml volumetric flask, and then you start a spectrophotometer and you take the readings one by one at 420 nanometers. So take the readings and prepare the graph with standards and compare the sample solution with that graph and calculate the concentration of nitrogen in the present sample. I will explain how to calculate the nitrogen in next step. In this figure, in this photograph, you can see different beakers. One small beaker, one big beaker. In big beaker, we kept phenyl disulfonic acid. We prepared this phenyl disulfonic acid with 25 grams of phenyl and with 150 ml concentrated sulfuric acid and with 35 ml of humic sulfuric acid. Then we prepared water bath, heated. Then the color of this phenyl disulfonic acid is this brown color. It is transparent like a slightly gold color, copper tinge, not gold. Copper and gold, when you mix, how it comes like that, slightly copper color, elemental copper color. Like this it will be there, phenyl disulfonic acid. Then second beaker, small beaker, after adding 2 ml of phenyl disulfonic acid and adding water, 10 ml of water and adding 10 ml of ammonia solution, then the color of the solution, yellow color. So you can clearly understand the color. Means in first beaker you observed yellow color. This type of yellow color comes for each and every nitrate sample. So based on the concentration of nitrogen, the yellow color of the sample increases. So we measure the concentration of this yellow color at 420 nanometers, and according to the absorbance, you estimate the concentration of nitrogen present in the water sample. Now you can see the standards, yellow color. First one is blank, second standard 10 micrograms, third standard 20 micrograms, fourth standard 30 micrograms nitrogen. Here what we did, in blank we didn't take any nitrogen solution, but in second standard 1 ml of 10 ppm nitrogen solution we have taken. In third standard 2 ml of 10 ppm nitrogen we have taken, and fourth standard 3 ml of 10 ppm nitrogen we have taken. And we did all the steps what I told earlier, and we developed the color, and here we measured the concentration, means absorbance, at 420 nanometers. Here I have given for each and every standard absorbance. For blank 0.032, for 10 micrograms nitrogen 0.149, and 20 micrograms 0.286 absorbance, and 30 micrograms 0.387 at 420 nanometers. These are the standards I observed when I treated with phenyl disulfonic acid. Here we tabulated the values, spectroscopic absorbance values. We prepared 4 standards, 1 blank, 3 with different concentration of nitrogen. First one blank, we got absorbance spectrophotometer values 0.032, and second standard with 10 micrograms of nitrogen in volumetric flask made to 25 ml. Here in this standard we got 0.149 absorbance. We have taken absorbance values at 420 nanometers wavelength, yellow color. And third standard we added 2 ml of 10 ppm nitrogen, means 20 microgram. We are using 10 ppm N, means 10 micrograms per ml. So we added 2 ml of 10 ppm. So 20 micrograms of nitrogen we added. We got 0.286 absorbance. In fourth, we added 3 ml, means 30 micrograms nitrogen. Then we got 0.387 absorbance at 420 nanometers wavelength. Now we prepared a linear equation according to these absorbance values. That is this equation ABS into 82.94 minus 2.70794. According to this equation, in second standard, we calculated based on 0.149 absorbance. We calculated according to this equation. I got 9.65 calculated value. Original value is 10 micrograms. In third, original value is 20 micrograms. I got 21.01 according to this equation. And fourth, I got 29.39 for 30 micrograms of original value. And unknown sample also we can get it from this linear equation. Now coming to calculations. Suppose unknown sample, how to calculate its nitrogen concentration. Here N concentration in ppm is equal to nitrogen content in micrograms obtained from the graph divided by volume of the sample taken in ml. Means first we should take some known amount of water for testing. Here, example I am telling, volume of water taken for the nitrate test 2.5 ml. Then we evaporated it. Then we developed the color and made to 25 ml. Then we got absorbance reading in spectrophotometer at 420 nanometers 0.56. Based on curve, linear equation curve, we got N content obtained through standard curve. How much? 43.739 micrograms from that linear curve standard from standards. Now we should calculate the concentration of nitrogen in the water in terms of ppm. Here N concentration in ppm is equal to 43.739 micrograms divided by 2.5 ml. So we got 17.496 ppm. ppm is nothing but parts per million. Here for each ml of the water we got 17.496 micrograms. Micrograms per ml is nothing but ppm, or milligrams per liter also ppm. ppm means parts per million. So here in this um, test we got nitrogen concentration 7.496 ppm. The same thing, calculations. I prepared a program, Excel program for estimating nitrogen in water samples. This is the program. You can feed the standards and their observance values, and you can feed them how much amount of water you used and final volume made and observance values obtained from the spectrophotometer, and finally you will get nitrate nitrogen concentration in terms of ppm, that yellow color. Here also you can see 17.49. What we got in manual calculation, the same thing we are getting in the Excel sheet. This is a very simple, easily you can calculate. Once you develop Excel program, then it is very easy to calculate. Generally, routine water samples you can do easily with this program. This is my address. I am Dr. V.V. Appara, Principal Scientist, Soil Science. I am working at CHS Vejalpur. CHS means Central Horticultural Experiment Station, Vejalpur, Kalol Taluk, Panchamal District, Gujarat, 389340. I am working in ICR, CAH, Bikaner, India. CH means Central Institute for Arid Horticulture. It is in ICR, Indian Council of Agriculture Research. It is at Bikaner. My WhatsApp number is 8780125279.